Hello everybody and welcome to video 6 in this Rust programming tutorial series. In this video, I'm going to be going over arithmetic, so really math here in Rust with different data types, as well as how we perform type conversions and how we cast one type to another. This is an important video. You may think you know how to do basic arithmetic, but if you've not done it in a statically typed language, then please watch through because there's a lot of nuances and stuff you need to understand, especially related to stuff like overflows, which we're going to talk about a fair amount. Now, of course, I will mention I do have my course, programmingexpert.io. If you made it to video 6, check it out. It's in the link in the description. Genuinely a great resource. We've had some great feedback on it so far, and I spent an incredible amount of time working on that course. I promise you it's some of the best work that I've ever delivered. So if you like this teaching content, then definitely check that out. Anyways, with that said, let's dive in here. So let's just have a look at some basic variables here and start to kind of get into arithmetic. So I'm going to say let x is equal to 9, and don't forget my semicolon this time, and then let y equal 10. Now we know by default these are going to be I32, but I'm going to change these to be U8 and to be I8. Now, first thing I'll show you is we do have a comment in Rust. I should have mentioned this earlier, but a comment is with 2 forward slashes. Now, anything after these 2 forward slashes on the same line will not be read by the compiler. It will just be ignored as a comment. And what I'm going to do here is just put the range of my, my U8, which is 0 to 255. And then the range here for my I8, we know is going to be negative 128 to 127. Now, the reason I'm doing this is I want to show you what happens if I put a value here that's outside of the range of this type. So for example, if I do something like 256. Now it may seem obvious, but if I go here and I run my code, you're going to see that I get an error and it says that the value 256 does not fit into the type U8, whose range is 0 to 255. So just keep that in mind when we are compiling here. If we have an overflow occurring, which is what this is, you can see here we have this overflowing literals thing, and while it says overflow a few times, we're going to get a problem because, well, this literal is out of the range for U8. And by the way, a literal is when we're actually typing out a primitive value here. It may not only be primitive values, that may be slightly inaccurate, but a literal is literally like typing 256 or typing 1 or typing 1.23. These are known as literal values. Anyways. Okay, so that's what happens when we do that. Now, the same thing would happen with I8, and if I try to do something like -9, we're going to get that same problem. It doesn't fit in U8. Okay, so that's fine. Next, though, let's move on to adding these values. So clearly, you may want to add these together. So let's say let z equal x plus y. We'll add a semicolon, and then we'll just print the result here. So take a guess at what you think the result's going to be here. If you think this is going to work, if it's not going to work, why it may not work. But let's go and let's run the code and notice that we get another error, right? It says expected U8, but found I8. There's no implementation for U8 plus I8. So even though as humans, this looks easy, we can add 12 plus 10. We know it's going to be 22. The computer cannot do this because they are different data types. We have an unsigned integer and we have a signed integer, and there's no implementation for how we add these two values together, even though they have the same number of bits. So keep that in mind. You just can't do this, right? I can't add types that are not the exact same. I would need to change one of these types to be able to add them. So if I change this to I8, then of course I'm going to be able to add them. This works fine. That's 22. But if I do something like I64 plus I8, you'll see we get the same error. There's no implementation for I64 plus I8. So this can be frustrating because sometimes you'll have values that are the same base type, like the same integer or same unsigned integer, but they have a different number of bits, and you need to convert one of the types to another type to be able to add them together, which I'm going to show you in a minute. Now, this is the same with floating types, of course. So if I have my F32 and then I have my F64, you'll see that we get the same problem here. Notice I can't add them together. Whereas now if I change this to be F32, and I add them, actually, what's this saying? F32 10, expected F32, but found integer, use a float literal. Okay, so it's actually telling me that I can't assign, I should have saw that before, a integer value, which is this, to a F32 type. So if I want to make this an F32 compatible type, I need to add my .0. Actually, I wasn't aware of that. Again, guys, I'm just learning Rust too, so there's going to be some times like that where I make a small mistake. Regardless, though, you get the point. You can see now that we're able to add. We get our value of 22 because we made these the correct float types. Awesome. Okay, continuing here, let's look at what happens when we do some division, subtraction, etc. So let's go something like U8 Let's make this something like 255, and let's make this 1. So now take a guess at what you think we're going to get when we add 255 plus 1, and we print this out. And notice that we actually get an error here. It says attempt to compute U8 max plus 1 underscore U8. The max is just the maximum possible value from U8, which is 255. Now this is saying this would overflow, and an overflow occurs when we don't have enough bits to represent the number that would be generated by adding these two values. So adding 255 and 1 together would generate an overflow, which means we actually can't run this code. We can't compile it because we know an overflow would occur, and well, we can't allow that in Rust. Now there is ways to make it so that you are able to overflow, but typically you do not want to be overflowing, and that's what's going to occur here if we try to do this addition. So to fix this problem, we would then have to cast both of these types to something larger, so something like U16, so we have enough bits to add them, and then we would be able to add them together. Again, we'll get into the typecasting in a minute, but I just wanted to show you some of that. Okay, continuing here, let's try to do something like y minus x. Okay, now again, we're going to get an overflow error here because we're going to have a negative value that we're trying to represent, and we can't do that, right? 1 minus u8 minus the maximum value of u8 is going to give us an overflow. Doesn't allow us to do that. Okay, now let's do some stuff that makes a bit more sense. So let's try to do 255 divided by 10. So let's try to do x divided by y. Now these are the same type, so this division should work. When I do my x divided by y and I run this code, notice that I get 25. Now this is not going to be a whole number division, right? I don't know exactly what 255 divided by 10 is, but it's not going to be 25. It's 25 point something because we have 5 more here. However, we're just getting 25 because the result of any arithmetic operation we perform is always going to be the same type as the two operands in our arithmetic operation. So we have the operands, which we're using, the operator, and that means our result is always going to be the same type of the operands, which is U8. So this will be of type U8, meaning we can't store a floating point value, so this does not implicitly get like an F32 type or something like that. And if I tried to, say, make this an F32, you'd see that we get an error because this operation returns a uint type. So let's see how we now actually get a floating point value. Well, let's change this to be an F64, and this will be an F64 as well. And as we saw previously, we need to add the .0 here, so this is a valid float type. Now let's do x over y, and let's see what we get. And previous error, what is it saying here? Oh, I need my semicolon, I keep forgetting it. Okay, let's go back. Let's run, and notice I now get my 25.5, which is the correct answer for this division. And now this type here will be an F64 because it's the same type as their operands. Awesome. Okay, so that is division. Now we have multiplication using an asterisk. Same thing applies here. We're going to get an F64 type if our operands are F64. So let's run this, and notice that I get my 2,550. All right, so those are the core operators: addition, subtraction, division, and multiplication. Now I want to quickly show you the mod operator. So the mod operator is a percent sign. I'm sure many of you are familiar with it. It's going to give us the modulus, or the remainder, after division of these values. So x mod y should give us 5 because 255 goes into 1025 times. Then we have a 5 left over. That's our remainder, and so that's what we'll get. Cargo run, and notice we get 5. All right, so now that we've looked at that, I want to show you how we do type conversions in casting and how we add values of different types. So first, let's look at how we can actually write literals as a specific type. So oftentimes in Rust, you're not going to explicitly define the type. You're just going to let the compiler do it implicitly for you. However, like if I'm looking at 255 here, the default of this is going to be an F64, right? The default type is F64 for floating point values. But what if I want this to be an F32 without explicitly defining the type? So without having to do something like F32. Well, there's a few ways to do this, but the first way is to simply write F32 directly after the number. So when I do this, I'm pretty much saying I want to treat 255.0 as an F32 data type. And we could do the same thing with 10 here. And now when we run the code, notice that this is all good and we get our value of 5. Okay, so that's one way. You can just write it like this. Of course, I could write something like, I8 as well if this was a valid type for it. Since we had the decimal, I wasn't getting the syntax highlighting before, and that's one way to do it. Now, another way to do it is just to use an underscore. So if I do something like 255 underscore I8, this will be the same thing. Let's prove it. So let's go 10 underscore I8 here. Let's do our modulus. Let's run this. And of course, I get an error because I accidentally put 255 here, which is out of the range. So let's just go 127 and let's rerun. And notice all is good now. Okay, so we can use an underscore to separate. And one thing to note too is that we can use multiple underscores to make our numbers more readable. So for example, let's just make this I64 so we have some more bits here. And I64, if I wanted to have 127,000, then I could do this, and that is equivalent to 127,000. So if I do that, actually, let's just go divided by y, and I run the code here, then notice this is good, and I get my 12,700. Okay, so that is one way to do it. The next way to do it is to write the as keyword and then the type we want to write this as. So I can write this as an I64, and this will accomplish the same thing. When I run this, I get this as an I64 data type. Now, this is also how you do explicit type conversion. So here I have my X, right? We know this is an I64. Let's now change this type here to be an I32 though. We know that we're going to get an error when we try to perform our arithmetic because they're not the same types. So what I can do here is I could say parenthesize my X, and I could convert this to an I32, or what would be better is if I convert my Y to be a I32, or to be an I64, sorry. So what I'm doing here is I'm essentially taking the type that has the least number of bits, in this case it's I32, and I am casting it to a type that has more bits than it, so I'm going from a 32 to a 64, and now this should allow me to perform this arithmetic. So let's go here and clear and run, and notice this works completely fine. I actually don't need the parentheses, but personally I like adding them just because it makes it kind of more clear, right? So if I don't add the parentheses, same thing works. Okay, so there you go. That is how you perform a, explicit type conversion. So as we saw, Rust will not automatically convert the types for us. We have to manually convert them. And here, what I'm doing again is I'm going from the smaller type to the larger type, because if I were to go the other way, then an overflow could potentially occur. For example, if I do X as I32, I believe this will be fine now because 64 to 32, I think 32 will be enough bits for this. But if it wasn't, then we would get an overflow. So that worked fine, but if this was a really large number, I don't know what the range is for 32. So actually, let me try something here just because I don't know what the maximum value is. So I'm going to go I32 : max to get the maximum value. I'm going to say that's as an I64, and then I'm going to add 1 to it. And I think this should just work by default because 1 will be an I64. Okay, so let's do that for X. And then let's try to convert X to be an I32. And we should get an overflow because we're having the value's too large to convert to an I32, right? Okay, so let's run this here. Let's go cargo run. And okay, so this is what I was talking about. So here we're getting an overflow without it actually telling us that there's an overflow. So we had I32 max as I64. We added 1 to it, and now we have one value larger than the maximum value that can be stored in I32. Then what we do here is we say, okay, we're going to take X as an I32 value, and we're going to divide that by Y, which is already an I32 value. Now, when we do that, we should be getting a positive number, right? If we're getting the correct result, but we're not. We're getting this really large negative number because what happens is we have an overflow. So when we try to convert X to the I32, we get a massively negative number because of kind of the way that this is structured. Now, when an overflow occurs, we actually use something called 2's complement wrapping to kind of wrap the value and convert it to a smaller value. I'm not going to get into that in this video, but that's what's occurring and why we're getting this weird behavior. Hence why you need to be careful here, and notice the compiler didn't actually catch this error because it wasn't written as obvious as when we had literals written in and we were kind of converting them and causing an overflow more obviously. So here, overflow occurred, compiler did not catch it, and well, that's no good. We don't want that to happen. So that's why I was saying you want to convert the smaller value to the larger as opposed to the other way around. Okay, now that we have looked at that, let's look at how we convert a string from user input into a number, and then we can end the video here because I think I've gone through most of the type conversion. Also, I will note that we could convert this to a float as well, right? So I don't want to do it in that format, but if I do something like 10 underscore F32, or I write 10 as F32, that's fine, so long as I can convert this number to a float. Okay. So let's have a look at grabbing user input again and then converting that string to a number, maybe adding it and putting it out on the screen. So let's say use standard output, our standard library, IO. Now let's create our string variable. So we're going to say let mutable input equal string new, and then we're going to say std, not st, io, : and this is read line, I believe, dot expect. Okay, and for read line, we're going to pass our mutable reference to the input. Okay, and then we're going to expect and say expected to read line. Whatever, that's fine for now. And then we could say println exclamation point, and for now we'll keep it simple and just print the input. Let me add my semicolons, and let's see if I mess this up. Quite possible. So let's clear and run. And I got a problem, not found in IO. Read line. Is it read lines? My apologies, guys. This is std in, sorry, and then dot read line. Just forgot that one part. Okay, let's try this now, though. Just confirm. And if I go here, hello, we get hello. Okay, great. All right, so now that we have our user input, let's convert this to an integer. To do that, I'm going to say let int input. And then I need to specify the type here for this conversion to work properly. So I'm going to make this an I64. Okay, and this is going to be equal to input dot trim. Now, what dot trim does is it's a method we can use on our strings, and it's going to return what's known as the escape character or the new line character that we're going to get at the end of the line when we hit enter to kind of submit what we typed. So if I go back here to my console, every time I hit the enter key here, there's a special character that's kind of fed into the terminal telling me to go to the next line and to execute, in this case, the current command. Now we're going to get that as a part of our input, but it's an invisible character that doesn't show up in the terminal. So when we print our input back, we don't see it, but it is actually there. So if we don't remove it using .trim, which is what .trim does, it removes that kind of invisible character, then we're going to get an error when we try to do our conversion. So make sure you do .trim first. We're then going to say .parse. Now .parse is what's going to return a result, which is going to parse this string and give us an integer if it's capable of being converted to the type int64. Then we are going to say .unwrap, and this is kind of similar to the .expect, except what this is going to do is it's going to take any valid kind of integer result here and unwrap it into the actual integer type and return that to us. That's what's going on. So that's what we need there: trim, parse, and unwrap. And then we can just print out here the int input. And for now, let's just go with something like +2, just so we can see if this is actually working properly. So let's go back to our terminal here. Let's go cargo run. Okay. And now it's allowing me to type. So let me type a valid integer like 123, and then we get 125. Nice. So the addition's working properly. Now let's see what happens if I type something that's not a valid integer, like hello. Notice I get a problem, and it says we called unwrap on an error value, so the result returned an error. We can't unwrap it, and so we get our runtime exception. That's what this is. Let's run this again. Let's go with something like 1, 2, 3, 4, 5. Okay, we get 1, 2, 3, 4, 7. Now let's just try with a negative value, something like -9. We get -7. Okay, so that is working as we expected. One more time, let's go with something like 9.8. We get an exception because this is a floating value, not an integer. All right. So let's clear that. So that is really all I wanted to show you in this video, kind of the different arithmetic operators, how you work with different types, how you perform a type cast or conversion. You saw we can do that using the as keyword, and then what happens when we have integer overflows, as well as how we convert a string to an int. We'll look at all of this throughout the rest of the videos. Of course, we're just slowly building and building and building, and we'll do some more advanced examples once we learn about some more advanced features. With that said, if you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in the next one.